In Module 5.1, we get to look at our first application of the calculus concepts we've been talking about so far. Specifically, we're going to look at how derivatives of functions can be used to consider the marginal cost, marginal revenue, and marginal profit for a business. So we start off with an example. Consider a company that manufactures fuel tanks for cars, and we're given a cost function that tells us their weekly cost in dollars for producing X number of tanks. So the first thing that we want to do is find the marginal cost function. So the marginal cost function is as simple as just finding the derivative of our cost function. So we'll take this term by term. The derivative of 10,000, since that's a constant, will just be 0. The derivative of 90 times x, using the power rule, that coefficient of 1 comes down as a factor in front. So that just becomes 90, and the original exponent gets reduced by 1, so that becomes x to the 0, or just 1. So the derivative of 90x is just 90, and then the derivative of negative 0.05x squared will be 0.1x. So now that we have that function, we want to find the marginal cost at a production level of 500 tanks per week. So we're going to substitute in 500 for x into that marginal cost function. Which in this case would give us a marginal cost of $40. So let's also take a look at the exact cost of producing the 501st item. So in order to get the cost of producing X number of items, we're going to go back to the original cost function. What we're interested in is the cost of the 501st item. So we'll start with C of 501. But what that actually tells us is the cost to produce all 501 items, not the cost for just that one individual item, just the 501st item. So what we'll do is take the cost function evaluated at 501, and we'll subtract out the cost function evaluated at 500. So this will be the cost of producing 501 items minus the cost of producing the first 500 items. So all we're left over with then is just the cost of producing that 501st item. And this will yield $42,539.95. So that's the cost of producing 501 fuel tanks minus 42,500, which is the cost of producing 500 fuel tanks. So the difference there is $39.95. So the question is, what do these two results tell us? So we came up with a marginal cost of $40 and the exact cost of $39.95. So essentially what we could say is that C prime of x, that marginal cost function, is approximately equal to, so $40, $39.95, there's not much of a difference there, is approximately equal to the cost of producing the x plus 1th item, so the 501st item, 450th item, minus the cost of producing all the items that led up to that 501st item, whatever item number it is that we're considering. Or another way to say that, more in plain English, is that the marginal cost so the marginal cost function approximates the exact cost of producing one more item. So when we look at the marginal cost function, evaluate that for some production level. In this case, we evaluated that at x equals 500. This tells us that to produce one more item, that next item is going to cost us an additional $40 to produce, approximately. And again, we're getting a very close approximation here. The difference between $39.95 or 40 cents is pretty negligible. So when we look at the marginal cost, we're evaluating the cost to produce one more item. So if we increase production by one more unit. So we can define each of the marginal functions. So our marginal cost function is just the derivative of our cost function. The marginal revenue function is the derivative of our revenue function, and the marginal profit function is just the derivative of our profit function. So in each of those interpretations will be the same. When we evaluate any of these functions for x, it's going to approximate the exact cost, revenue, or profit if we increase production by one more item. So let's a quick recap here. Hopefully this is review, but we'll cover this quickly. A question to make sure we know how to answer is, how do we find our profit and revenue functions? So in some problems, we'll be given a profit function, in other cases not. If we're not given a profit function, then we'll most likely be given a revenue function and a cost function. And the difference between those values gives us our profit function. So however much money we bring in minus however much money we had to spend to produce those items gives us that total profit. So profit is always going to be equal to our revenue minus our costs. If our revenue function isn't given to us specifically, then that's something we might have to establish as well. So revenue can always be calculated as the number of items sold, so X, times the price that we're charging for each item. So if we sold 10 items at $10 a piece, that's $100 in revenue. So revenue can always be calculated as units sold times price per unit. So again, those are going to be two rather simple formulas to keep in mind if the profit function isn't stated explicitly or if the revenue function isn't stated explicitly. So in addition to marginal profit, marginal cost, marginal revenue, we can also look at marginal average cost, marginal average revenue, marginal average profit. So the same idea applies here. To find marginal average cost, we're just going to take the derivative of the average cost function. So this would just be the derivative of the average cost function, which is our cost function, divided by x. So we would take our cost function, put that over x, simplify that expression, and then take its derivative. So similarly, the marginal average revenue function is just the derivative of the average revenue function. And the marginal average profit function is exactly the same thing as the derivative of our average profit function.